Assalamualaikum warahmatullahi wabarakatuh. Very good morning. So for ECS246 civil engineering material, we have choose the green material as an innovation for sustainable material. So my teammates, which is me myself, Tengku Aris bin Tengku Shisha, Dani Syaikal bin Bustam, Ahmad Syamil bin Muhammad Zulkarnain, Suhaib bin Yaakob. So moving on into the introduction, green materials are sustainable, eco-friendly, and source-efficient materials that selected in use in building construction with the intention of minimizing environmental effect, protecting natural resource, and fostering sustainable development based on factors like energy efficiency, recyclability, low embodied energy, reduced carbon footprint, use of cycle of renewable resource, and minimal adverse impact on human health and environment. These materials are careful chosen. For the introduction for the first material that we chose is rice husk ash. It's one of the green material that can be used in construction. The result of burning of gassing rice husk ash, the outer covering of rice grain is known as rice husk ash. As pozzolanic additive or an additional cementation ingredient in construction of building, rice husk ash is frequently developed. It has quality include a high silica concentration, pozzolanic reactivity, and low carbon content that make it useful building application. When used in place of cement, rice husk ash can improve the strength, durability, and workability of concrete while lowering the amount of greenhouse gases released during the cement manufacture. Additionally, the use of rice husk ash in building helps to utilize agricultural waste and lessen the impact of trash disposal on environment. So the methodology, which is how the rice husk ash is manufactured, starting by the collection and storage of rice husk from the paddy field, cleaning and pre-treatment, combustion process, which is the burning of rice husk. The ash is collected and stored, and the rice husk ash is fine and quality control for produce more finest particle. So moving on, how to use rice husk ash in concrete. Rice husk ash was collected by combustion of gassing rice husk ash when were finally ground to achieve the desired particle size distribution. A mixed design was conducted to determine the appropriate proportion of cement, aggregates, water, and rice husk ash, taking into account specific characteristics and performance requirements of the concrete. A portion of cement content was placed with rice husk ash, typically ranging from 10% to 30% of the total cementitious material content. The aggregates, water, cement, and rice husk ash were thoroughly mixed to achieve homogeneous mixture. Following standard concrete production produced such as batching, mixing, and curing. The fresh and hardened concrete properties include workability, compressive strength, durability, and other relevant characteristics were tested and evaluated. The results were compared to control concrete mix to assess the effectiveness of rice ash in improving concrete performance. So how about the benefit of rice husk ash for the environmental? By lowering the requirement of cement, which has a substantial source of greenhouse gas emission during its manufacture, it lowers the carbon footprint of concrete. Second, it makes use of rice husk by a byproduct of agriculture, turning it into a useful substance in minimizing trash disposal. The use of rice husk also promotes resource efficiency in the building sector by lowering the cement content of cement and conserving natural resources like limestone and clay. The benefit help building practice to be more environmentally friendly, reduce waste, and save natural resource. For the benefit, second benefit, which is for the economic, it allows for cost saving and is reduce the amount of cement needed in concrete production. By replacing a portion of cement with rice husk ash, construction project can achieve cost efficiency without compromising the quality or performance of the concrete. Additionally, the use of rice husk ash creates a value-added product, transforming an agriculture waste into a valuable construction material. This not help in waste reduction, but is also the potential to generate economic opportunities. particularly in regions with rice production, which is Malaysia, by utilizing and commercializing the rice ash resource in the construction industry. So, in terms of industrial benefit, rice ash concrete gains strength, durability, and workability thanks to rice ash. It improves the mechanical characteristics such as compressive strength and abrasion resistance, which result in concrete construction that operate better. Rice ash can be used in various applications beyond concrete, such as in the production of ceramics, insulation, material, and soil stabilization. And for the community, rice ash offer low in volatile organic compound, contributing to improved indoor air quality and creating healthier living and working environment. By incorporating rice ash in construction material, communities can contribute to sustainable development, resources conservation, and a cleaner environment. What is the use of rice ash in Malaysia? Rice ash as a partial cement replacement. Research conducted by Shidan et al. Investigated the effect of rice ash as a partial replacement of cement in concrete. The study demonstrated the improved compressive strength and workability of concrete with various percentage of rice ash replacement. Incorporating rice ash in lightweight concrete. A study by Aziz explored the use of rice ash as a pozzolanic additive in lightweight concrete. The research highlighted the positive impact of rice ash on the density reduction and thermal properties of lightweight concrete. Incorporating rice ash in brick production. Rice ash conducted by Nurul Ain investigated the effect of incorporating rice ash in manufacturing of bricks. The study demonstrated the improved mechanical properties and reduced weight of the brick when using rice ash in bricks.
And then for the mixed proportion concrete mix design, so table 1 makes a proportion, a sum of various concrete mixture. So for the one that I see is C50, 50, 550 and 20, which is the cement used is 445. Then the rice ash is 105. With the fine aggregate 490 and coarse aggregate 1200, which is water 16.5. And then the super plasticizer with 5.5. The water binder was 0.3. And then the sum is 90. Then moving on to the second table, which is the compressive strength of rice ash blended with concrete mixture. So as you can see, for the 550 stroke 20, which is the compressive strength at day 3 is 52 megapascal, which is quite high. And then for the second day which is 70 megapascal, and then 28 day which is 87. And then for the last which is 60 day, which is 92 megapascal, which is the highest that we can get. So next this is table. Next this is the graph is cement replacement with total charge pass columns. And as you can see, the graph is here. And then the second graph, which is W/B ratio to versus saturated water absorption percentage, which is the highest water absorption is RHA, like 0% rice ash, which is the lowest RHA is 30% of RHA use being substituted into the cement. The water absorption about 2%.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Danish Haikal bin Bustam, and I would like to present about my part, which is green materials that we use is palm oil fuel ash, or what we call as a POFA. So let's move to the introduction. Palm oil fuel ash or POFA is a byproduct obtained from the combustion of palm oil biomass. It is a waste material composed of silica, alumina, iron oxide, and other minor elements. POFA can be used as a supplementary cementitious material in the product of concrete. The pozzolanic properties of POFA improve the strength and durability of concrete structures by reacting with calcium hydroxide and forming addition calcium silicate hydrate. POFA reduces the amount of cement required in concrete production, thus lowering the carbon footprint of the construction industry. POFA can be used as a filler material in the production of bricks, tiles, and panels, reducing the demand for traditional materials like sand and clay. POFA has potentially applications in geotechnical engineering, including soil stabilization for road construction and embankment reinforcement. POFA also have a proper processing and research are important to ensure consistent and reliable performance of POFA in different applications. Utilizing POFA helps in waste management by utilizing a waste product that would otherwise be disposed of in landfills. We move to the methodology. How we want to preparing of palm oil fuel ash, or what we call POFA. Firstly, we need to collection and salting. Then we go through the combustion process, and then we go to cooling and collection. For the third process, grinding and sieving. After grinding and sieving, we need to have a quality control and characterization. And lastly, we need to packaging and storage. Let's move to the finding. Using palm oil fuel ash or POFA in a concrete. How we want to use POFA in the concrete? Firstly, we need to collect and prepare the POFA. Obtain for POFA from palm oil biomass combustion sources such as EFBS, PKS or POME. Ensure the collected POFA is free from contaminants and properly stored. Next, concrete mix design. Design the concrete mix incorporating POFA as a partial placement for cement. Consider the appropriate percentage of POFA placement based on previous research and test results. Determine the water to cement ratio, aggregate proportions, and any additional admixtures required. Third, sample preparation. Measure the quantities of cement, POFA, aggregates, and water according to the mix design. Thoroughly mix the components using a concrete mixer to ensure uniform distribution. Cast the fresh concrete into molds, such as cube or cylinders, for testing purpose. After that, we need a testing and evaluation. Conduct compressive strength tests on the cured concrete samples at specific age, which is 7, 28, and 56 days. Evaluate the mechanical properties of the concrete, including compressive strength, tensile strength, and flexural strength. Comparative analysis. Compare the test result of the POFA incorporate concrete with reference samples, concrete without POFA or with different cement replacement. Analyze the data to determine the effects of POFA on the concrete's mechanical and durability properties. Assess the potential improvements in terms of strength, workability, and durability performance. And lastly, optimization and fine-tuning. Based on the test result analysis, optimize the POFA replacement percentage if needed. Adjust the concrete mix proportions and water to cement ratio to further enhance the performance of POFA incorporate concrete. Conduct additional tests if necessary to investigate specific properties or address any concerns.
So move on next to the benefit of palm oil fuel ash, which is POFA. There are several benefits that we can get from palm oil fuel ash. For example, if we look into the environment side, POFA help in waste management by utilizing a waste product that will otherwise be disposed in landfill. So here we can see that if we use POFA in construction, we can reduce the number of palm that been disposed in landfill. Next, the use of POFA in concrete production reduce the amount of cement required. that's lead to a reduction in carbon dioxide emission. As we know that cement production produce a lot of carbon dioxide emission. Next, by incorporating POFA into construction material, the demand for traditional resources like sand and clay can be reduced for conserving the natural resources. Next, if we look from the economic side, when we use POFA in concrete, we can reduce the amount of cement required, resulting in potential cost saving in construction projects. The reason here is palm oil fuel ash or POFA is much more cheaper compared to the cement. By converting a waste material into available resources, the utilization of POFA adds economic value to the palm oil industry. Next, we move on to the community perspective. The utilization of POFA aligns with the principle of sustainable development by promoting waste recycling and reducing environmental impacts. The use of POFA in concrete can enhance the strength and durability of structure, contributing to safer and long-lasting infrastructure within community. Next, we move on to the industrial perspective. By incorporating POFA into concrete, it can improve its mechanical properties such as strength, durability, and also leading to higher performance construction material. The utilization of POFA offers opportunity for devising the product portfolio in the construction and building material industry. So people will attract to this new product compared to the old product. Next, we move on to the use of palm oil fuel ash in Malaysia. For example, palm oil fuel ash or POFA can be used in concrete production. POFA has extensively studied as the partial cement replacement in concrete production in Malaysia. Research has shown that incorporating POFA in concrete can improve strength, durability, and other mechanical properties. The use of POFA in concrete reduces the carbon footprint of the construction industry by lowering the cement consumption. So we can produce a better cement with POFA. Next, construction and building material. POFA has been explored as potential additive or filler material in the production of construction material such as brick, tiles, and also panel. By incorporating POFA into this material, the demand for conventional resources can be reduced, leading to more sustainable practice. As we know, our country now is promoting a more sustainable practice compared to the conventional resources. Polyzolanic properties contribute to the enhancement of material properties and also performance. Beside both of that, POFA also used in geotechnical engineering. POFA has shown promise in geotechnical applications such as soil stabilization. By adding POFA into the soil, it can improve the engineering properties of problematic soil, such as expensive or weak soil. It can enhance their stability and also load-bearing capacity. The utilization of POFA in geotechnical projects can lead to more efficient and cost-effective solutions. Last but not least, research and development. Malaysia have been actively involved in research and development efforts to explore the full potential of POFA. University research institutions, universities, research institutions, and industry players have conduct studies to understand its properties, behavior, and also potential application. This research endeavor aims to promote sustainable practice with valorization and development of innovative products and technologies.
Based on the discussion of rice husk is a viable and eco-friendly option for the construction industry. Moreover, the thermal insulation properties of rice husk offer a potential for improved energy efficiency in buildings, thereby reducing reliance on heating and cooling system. However, certain challenges must be addressed, such as achieving the adequate compressive strength and consistent polyzonic activity. For discussion of palm oil fuel ash, POFA enhancing concrete strength and durability, they can replace a portion of cement, reducing carbon emission and preserving natural resource. Additionally, POFAs improve workability and mitigate thermal cracking in large structure. However, ensuring consistency quality of POFA remains a challenge due to a variation in their characteristic. In conclusion, replacing cement with rice husk in concrete has a potential to contribute sustainability effort by reducing carbon emission, promoting waste utilization and enhancing concrete properties. However, further research, quality control measure and environmental assessment are required to fully understand a long-term performance and environmental implication for incorporating rice husk as in concrete. In summary, incorporating POFAs in concrete provides a range of advantage and consideration. Throughout the research, testing are crucial to evaluate the long-term performance and durability of POFA in concrete, particularly concerning factors like freeze-thaw resistance and chemical degradation. In conclusion, the use of POFA in concrete offer potential benefits such as a reduce of carbon emission, waste utilization, and enhanced concrete properties. However, responsive resourcing, quality control, and environmental assessment are necessary to ensure the sustainability of integration of POFA in concrete production.
So moving on to the result. For the first table, which is POFA polyzonic reaction, cement plus water will produce calcium silicate hydrate plus calcium hydroxide. The second one, silicon plus oxygen will produce silica oxide. And the third, silica oxide plus calcium hydroxide will produce secondary calcium silicate hydrate. So the table 2 show physical properties of chemical composition of POFA. Which is it show the different amount of OPC that being used, and then the percentage of POFA used for each one of them. So for the table 3, show the tensile and flexural strength of concrete at day 7, 14, and 28 day of curing. So show the average tensile, which is day 7 for 0% of POFA use is 1.15, and then for day 14 1.31, and then day 28 1.78, and then it showed the highest average tensile strength. It show at 25 of POFA is used, 25% of POFA used, and then the average tensile strength, the highest is 0.91 at day 7, 14 day at 1.03, then 1.70 at day 38. And it showed the average flexural strength is at 15% of use of POFA. Day 7 is 1.96, 2.82, and 4.31 at day 28. Table 4 show a fineness on POFA on the compressive strength of concrete. Then for the 20% that we use of POFA is for the which is the highest is 20% of POFA, and then the compressive strength at day 7 is 71.1, on day 28 85.9, on day 60 88.5, on day 90 is 91.5, which is highest we can get on the day 7 28 60 and 90.